Hello again, everyone. We have another video solving another problem, which we have over here. A 20,000 pound force is applied to a horizontal circular area having a diameter of 3 feet. The force is applied at an angle of 60 degrees with the horizontal area. Determine the normal stress developed in the area. So let's solve this problem. So we have an area, a circular area that has a diameter of 3 feet. Okay. By the way, 1 apostrophe denotes feet. 2 apostrophes denotes inches. 1, I repeat, is feet. This is equivalent to reading it as 3 feet. So I have an area of 3 feet, or a diameter of 3 feet for the circular area. Now we have a force. The question now is the normal stress, so we can have it P over A. Note that for a normal stress, the P is perpendicular to the area, meaning the load is perpendicular to the area. Now we have it in the problem that the force is applied at an angle of 60 degrees with the horizontal area. Now to visually illustrate this situation, we have, if we look at this in a frontal view or a horizontal view, we'll have it in this view. And then we'll be able to visualize that the load is applied at an angle. So this is now the load 20,000 pounds. Okay? Now, 60 degrees simply is the area the angle at which the load is applied. So we can write this between the load and the horizontal area. So 60 degrees is between the load and the horizontal area. So this is now 60 degrees. So this is the area, this is the load. Now we need to solve for the normal stress. I repeat, the normal stress occurs when you have an area and a load where the load and the area has an angle of 90 degrees between them. So to solve the normal stress, we need the component of this load that is vertically going downward. So to attain this situation, okay? So judging by this figure, we can say this is 20,000, this is 60 degrees, okay? 60 degrees, 20,000, we can apply SOHCAHTOA. Okay? So we have, the load is 20,000, that is opposite of the 60 degrees over the hypotenuse. So that is opposite hypotenuse, so that is from the SOHCAHTOA. If you remember your trigo SOHCAHTOA, so this is so that is 20,000 sine of 60 degrees. 20,000 sine of 60 degrees, that is your, this one. Okay, I'll just blow it, have it in blow up. The 20,000, the load that has an angle of 60 degrees with the horizontal, what we need is this vertical component. So from your SOHCAHTOA in your trigonometry, we need the vertical given the hypotenuse. So hypotenuse is given, okay? We can also use ka because hypotenuse is given. Next given is this side, or what we need is the vertical load or the vertical component. And with respect to the angle that is opposite, no? This is the adjacent, this is the opposite, so that since that is opposite, we cannot use ka, instead we need to use so. So to use this, we have sine of 60 degrees is equal to the opposite, which is this one, the P, if we denote this as P, all over the hypotenuse, which is 20,000. Rearranging this, we will get 20,000 times sine 60 degrees is equal to P. So that's why we have 20,000 sine 60. All over the area is circular, so we have pi over 4, the diameter is 3 feet, 3 feet squared. So we'll have it here. The stress is now equal to 20,000 sine 60. 20,000 sine 60 Yeah, with the answer divided by the shift pi over 4, 3 feet squared, the area of the circle with a 3 feet diameter. Now have 24540, 2450 then, 2450.35, 2450.35. This is a unit of pounds per feet squared. Okay, we can use another form. We can change pounds into kips, so we can have the answer in 2.45 kips per feet squared. Okay, since 1,000 pounds is equal to 1 kip, so we can have 2,450 into 2.45 kips. Or we can also have it in this form, 245 KSF. Okay, 2.45 KSF. KSF means kips per square feet. Okay, that is now the normal stress.